Here we're going to be looking at solving equations for a variable x, where these equations are going to contain rational expressions or fraction functions. So we need to be mindful when solving these types of equations because we know that division by zero does not exist. So to help us along the way, the following steps are some strategy for solving these types of rational equations. So the first step that we want to apply when solving rational equations is to begin by finding a least common denominator, or LCD, among all of the rational expressions. Now, recall from algebra that a least common denominator is the product of the factors that appear a maximum number of times in any one denominator. So to find the least common denominator, we want to make sure that we factor each denominator separately and that we also make note of how many times a factor is appearing in any one denominator. Now, since division by zero does not exist, in step 2, we're going to go ahead and use that least common denominator we just found to identify the zeros of the denominator. So to do this, to find where our rational equation does not exist, we're going to set the denominators, or the least common denominator, equal to 0 and then solve. So once we have the least common denominator and have identified the undefined values for the equation, so we can now, in step 3, remove the fractions of this rational equation by multiplying both sides of the equation by our least common denominator. Now, be careful when doing this that you distribute that least common denominator through to each term to prevent algebra errors. Now, once we have removed the fractions, we're ready to start solving. Now, since we know that rational expressions do not exist if their denominator is equal to 0, step 5 is of the utmost importance. After you're done solving your equation, we need to make sure that we check any and all potential solutions by substituting these values back into the original equation to make sure that it's satisfied. We also want to be checking any potential solutions against the zeros of the denominator to make sure that they're actually in the domain. Now, keep in mind that if you find a potential solution that matches one of the zeros of the denominators, it's not actually a solution. We refer to these as extraneous solutions, which are excluded from the equation's domain. So now that we have established some strategy for solving these types of questions, let's go ahead and practice.